Hey everyone, in this video I'll be describing the solution to container with most water. So in this video I'll be introducing the problem, explaining the solution and how to implement it, and then wrapping up with the runtime analysis. So in this problem you're given an integer array which is essentially a height map. So each integer in the array represents a line of with the height that the number in the array is, and at the index of I. So you're supposed to find the two lines which can contain the most water if they made a container. So that might be a little confusing, so it's really easy to just look at the test case to see what they mean. So in their test case, you would have these lines here represented by this array. So the first line would be a height of 1, then this one is a height of 8, 6, etc. And the two lines which can hold the most water would be this line here and this line here. And that's because 8 and 7, the smaller wall would be of 7 length. So the height essentially of this rectangle is 7, and the base between them is just the difference between their indexes. So this is at index 1, and this is at index 1 to 8. Yeah, so this is at index 8, so 8 minus 1, that's 7. So the base of this rectangle would be 7, and the height of this rectangle would be the minimum of 8 and 7, which is 7. So 7 times 7 is 49. So essentially you're trying to maximize this area of the rectangle. Alright, so now let's get into how the solution works. So we know we are trying to maximize the area of the rectangle. So let's first define what the area of the rectangle is. So if we have this rectangle, the base would be, let's just say we have a pointer I and a pointer j. So I is one index, the number at one index, and j is the number at the other index. So let's just like say I is this one and j is this one. So the base would be j minus I. So that's the length of this base. And the height would be the minimum of array I and array j. So that's the height. So whichever one of these lines is smaller, that's going to be the height of our rectangle, because then you can hold this much water. And so we're trying to maximize this area, base times height. So we can apply a greedy approach to solving this problem. We can first start with the rectangle with the largest base. So we start I at the first number in the array, and j points to the last number. So this maximizes our base, and we can simply perform a computation to get the area of this initial rectangle. Say it's with, let me just clear out the screen a little. So say the initial rectangle is with one wall this high and one wall this high. We can just compute the area of this initial rectangle with the maximized base. Now an important observation is that to get a rectangle with a larger area, we must shrink the base because we already have the largest base. And the second important observation is that when shrinking this base, it's futile to try to shrink the taller wall, because let's say we found a super tall wall next to here and shrunk this to here and hoping that we can hold more water with this taller wall. It won't help us because this short wall is still here and ruining our plans. So the greedy approach comes in where we know that to make a larger area, we must shrink the base somehow and try it out. So what we do is we move I over 1 because I is smaller. Is the smaller between these two walls. Like j is this tall, I is this tall. So we would want to move I 1 over and see if that makes a larger area, because that would be the only possible way to get a larger area with a smaller base, is if you somehow run into a taller wall on this side well, now suddenly you can get more water. And then you just keep on doing that until you cannot shrink the base anymore. So until like I and J meet up somewhere in the middle here, and yeah, and you would just repeatedly use this greedy logic. So let's just say I is shorter here. Let's just say now I is a little taller here with this base. Now you can use the same logic. We need to test if we can shrink the base and get a larger area. So in this case, we would move J because moving I is pointless because I is already the taller wall. So we want to move J to see if we run into an even taller wall to make our height larger. So yeah, and just to summarize that in a concise way, the algorithm essentially first starts off with the maximum base and then tries to see if can I make the base smaller but increase the height enough so that the area is larger. And that's exactly what we do by greedily changing the smaller wall to see if we can increase the height. And let's see how to implement this strategy with code. So here's a solution I coded up. And as you can see, we'll use I as our left, left wall, and J points to the index of our right wall. And so while we can still shrink them, so while I is less than J, we compute the area formed by these two walls. So J minus I, that's the base, and then the minimum height of each wall. So in this case, we would start with I pointing here, I is 1, and J would be 7. And then so we'd find an area of 7. And then we'd set that to our max area because that's the biggest one we found. And then so then we try to shrink the base and see if we can compensate with that enough for an increase in height. So if our wall at the index of I is shorter, we'll move I 1 over, and otherwise we'll move J 1 back. And so this will greedily move the walls so that the smaller one will always get shrunk in to try to find a taller wall. And we just keep on shrinking this base until we can't shrink it anymore, and then we just return the maximum area we ever came across like doing this algorithm. And yeah, let's just submit this to prove that this works. Yeah, this was I just submitted a couple of times before, and yeah, as you can see, it's really fast because we're essentially just going through the array once by starting I and J at either end and forcing them to get closer and closer to each other. So this will be an O of n algorithm. So yeah, that's about it for the video. I hope you guys enjoyed it and found it a good video, and yeah, I'll come back with another video tomorrow. Thanks for watching.